Aloha, this is ITS128, and today is October 27th, and we're in Chapter 6. We're talking about functions. Let me share my screen. Let's see, let me put this over here first, and share my screen. Just close this. Share my screen. Don't need to see that. Okay. Just 1 second here. Okay. All right. Let me close this. All right. Here we are in week 10, and last week Thursday we started functions, and today we're going to continue with functions. We're going to get almost to the end of the chapter, and then on Thursday we'll finish the chapter, and then next Tuesday and Thursday we will do these Xylabs projects. Okay, so here we are in chapter 6, and we covered 1, 2, and 3 last Thursday. We didn't get very far, so today I'm going to try to get all the way through down to like scoping or something around there, and then we're going to, I guess we're going to read, and then this, I'll save this stuff for Thursday. Function arguments, which is just more about passing arguments and functions. Okay, so last week we finished up returning where we would create a function, create functions that would actually return values. So in this case, for example, we defined a function called compute square, and it had one parameter. And what the function would do is it would take that parameter and multiply it by itself and then return that value. And when you have a return value, then wherever the function name along with the argument existed in a statement, it's the right side of an assignment statement, usually the right side of the statement, that this word, the function name along with its argument, that gets replaced with the return value. So in this case, the argument is 7. So when this thing executes, it executes with a parameter of 7. It takes 7 times 7, which is 49, and that's the value that's returned. So this, along with the actual argument, this whole thing gets replaced with 49, with the return value. And so that means num squared, this variable gets assigned the value that is returned. Okay, so that's an example of arguments and return values. So let's go to section 6.4, the concept of dynamic typing. Okay, so dynamic typing means that it's sort of, well, where the programmer can pass. This has to do with just functions. The programmer can pass any type of object as an argument to a function, and as long as the operations inside the function are consistent with the type of the argument, then everything is fine. It just performs the operation, and then returns a value accordingly. So for example, let's say you have a function called add, and it takes 2 parameters, x and y, and it adds the two, it adds x plus y, and then it returns that value. So it turns out that the plus operator works with either numbers or strings. If it's if the operators or if the operands are numbers, then the plus operator acts like addition, just like the mathematical addition operation. If the operands are strings, then the plus operator in between two strings means concatenate the two strings. It means connect them together and to make one string. And so if x and y are strings, then this operator works fine, the plus operator works fine, and it ends up concatenating. So here we have in this example, we are going to add 5 plus 7, and that's going to, the 5 and the 7 are going to go in there, and it's going to see that it's numbers, and so it's going to add them. It's going to result as 12, so it's going to return a value of 12. So then this thing here gets replaced with a 12, and so it's going to print out 12. But in this case here, with this function call, these arguments are strings, and so when this add function is called, this executes. These are two strings, and so this is going to concatenate. So this is going to concatenate Torah with Bora, and it's going to output Torah Bora. So let's see how this run this. Okay, so the first thing we've done is we've defined a function called add, and then we're going to call add where x is 5 and y is 7, and then we're going to go up here. This arrow is what's going to be next. It's going to add the two, and it's going to return a value of 12, and what gets printed out is 12. And so once this statement is done being executed, then this statement starts to execute. It does the same thing, calls add, but with Torah as the x and Bora as the y. And so when this statement executes, we see that it returns Torah Bora concatenated together like that. And then we're done. Now, an error can occur, of course, if you pass a number and a string, because this plus operator does not work when one operand is a number and the other operand is a string. Okay, so that would cause an error. And this concept of where it sort of depends on the context. The concept is called polymorphism, which means that well, you can look it up, but poly means more than one, so it can have more than one meaning depending on different things. And in this case, it's the type of the operands. And so it's the same, you define the function the same, but in some instances, the function behaves differently than other instances. And in this case, sometimes the function behaves where it's actually adding two numbers together, and in another case, it's the same definition of the function, but it when it executes, it treats the plus operator as a string concatenation rather than adding two numbers. Same with the asterisk operator, where if it's two numbers, then it multiplies it. If it's a string and a number, then it repeats it. It repeats the string that many times, the number many times. So this is going to result in this. Okay, so Python uses dynamic typing to determine the type of objects as the program executes. So we can have a num variable be assigned a number, in which case now num the type of num is a integer or number type, whether it's number or floating point. And then some other time we can define it as if we do this, we are defining num as the character 7, not the number 7, but the character 7, the strings of the string, and it's a single character, and it's the 7 character. So in this case, num is a string type. In this first case, num is a number type, and in this case, it's a string type. I guess integer type versus a string type. So num can change depending on the value it references. And the interpreter is responsible for checking to see that when we start doing operations like a plus, that the operands are correct, they match, the operands match, or it's something that will work. Otherwise, an error is defined. And so this is called dynamic typing. And lots of languages have dynamic typing. Some language, not all languages though. For example, in a language like C or C++ or Java, it's static typing, which means when you declare the variable or when you define the variable, it takes on a certain type, or you assign it a particular type. In C#, C# is another language, or Java, you actually have to declare the variable up at the top. In Python and in other languages like PHP, just to declare a variable, you simply have to name it and then assign a value to it. So something like if you want to use, if you want to use num, the first time you see num like this, num equals 5, that's the first time num ever appears in the program. Num is declared as a variable and it's assigned a value. So it's kind of two things. Whereas in a language like Java or C# or C++, you have to first say that it's an integer, int num, and you can say int num equals 5. But the fact of the matter is, first you declare the integers, first you declare the type of this variable, and then after that you can do operations on it or with it using that type. And once you declare a type for a variable, you can't change it. Okay, so it's statically typed. And so that may be inconvenient, but it's very good if you're writing large programs with a bunch of people, and you want to define it, and then you want to let the system tell you if you're using it incorrectly. So if you define num as an integer in C#, for example, it would be parentheses, or it'd be int num equals 5. Then num is an integer. And later on, if you came along and you tried to just say num equals quote 7 end quote, it'll say it's an error. You can't assign a string to an integer type. So that's the difference between static typing and dynamic typing. And Python uses dynamic typing. So polymorphism refers to how an operation works depending on the involved object types. Yes, that's what it means. A programmer can pass only string that's silly. Programmer can pass any kinds of arguments, just has to be consistent with how it's used. Static type languages require the type of every variable being defined in the source code. That's true. A dynamic typed language like Python checks that an operation is valid when the operation is executed by the interpreter. If it's invalid, then a runtime error occurs. That's true. They cleverly call this duck typing. If it walks like a duck, swims like a duck, quacks like a duck, then it's a duck, kind of thing. So reasons for defining variables. Now, it's dynamic typing, but as I showed you a couple weeks ago, There's even, you know, typing that's more flexible than this dynamic typing. And where in a language like PHP, if you try to do something like adding a number plus a string, you recall that in PHP, the plus only adds numbers. If you want to concatenate strings, you use a period, okay? So the concatenation operation for us in PHP is a period. Well, if you come along and you say 5 plus and then a string, it's going to say, oh, string, well, a string is a value of 0, so it's going to be it's fine, sure, you can do that. It's just going to add 0. So any string, if you try to use that in an expression where you're adding numbers, it's going to be interpreted as 0. In some languages, I think PHP is like this. If the string starts with some numbers and then followed by some letters, it'll take the first few, it'll take all the digits up, the digit looking things all the way up to the first non-digit, and it takes that and it uses that as the number. So it interprets that string as that number. So there's various levels. I say that there's various levels of dynamic typing, and Python is not the most dynamic, but it's more dynamic than other languages like Java or C#. All right, so reasons for defining functions. Well, the reasoning is obvious. If you're going to repeat some code, it's nice to put it in a function. It's also nice for organizing things. In this, it makes programs easier to understand. So in this case, we've defined a function to convert from us. Okay, in this little thing, this little program, the user or the program asks you for the number of steps that you've walked, and it's going to convert that to how far you walked. It's going to convert the steps to how far you walked, and it's going to convert the steps to how many calories you burned when you walked. And the formulas are that this thing defines is it defines the number of feet per step. So every step you take, you've traversed 3 feet. Apparently, I guess. With me, it's probably less. I got short legs, so my wife has longer legs. I'm taller than my wife, but my wife has longer legs than me. And so when we're walking along, it's like I'm going ding, 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 and she's just going ding, ding, ding. That's why I don't like to take walks with her, because she always walks faster than I do. Anyway, so we take the feet per step, and we multiply that by the number of steps, and that's how many feet we've traveled. And so this thing converts the number of steps into the number of feet you've traveled, and so it returns this feet value. For steps to calories, it has a different conversion. If you walk, if you walk for a minute, you burn 70 calories, and so here we're gonna calories per minute walking, steps per minute. If you walk for a minute, that's about 70 steps, and for each minute you walk, you burn 3.5 calories. So that means for every 70 steps, you burn 3.5 calories. That's what that means. And so if you think about it, the conversion, I can pull up my whiteboard and show this to you, but it's, I don't have to do that now. Though, just believe that the formula is number of steps divided by the steps per minute will give you a minutes value. So you're going to input some steps. The first thing it does is it converts it to how many minutes that took. If you get 500 steps, this is going to convert it to how many minutes it took you to walk the 500 steps. And now you have a value for minutes, for walking minutes. And we know that for every minute you walk, you burn 3.5 calories. And so we have this minutes value, and we multiply it by the number of calories per minute walking, which is 3.5, and you end up with the calories value. And so that's what you return. So you can see that this is easier to see because first you input the steps, then you just convert it. However the function works, you convert it to a feet value, and then you print it out. And then you take that same steps and you use it as an argument into this steps to calories function, and it returns a calories value, it returns this, and then it prints that out. So when this executes, it looks like this. It asks you the number of steps, 1,000 steps, and it says, oh, you must have traveled 3,000 feet and burned 50 whole calories. It's about a half a beer. No, it's less than half a beer. All right, but if this did not use functions, then you would just, you'd have this calculate. You would define these values up at the top, and then you'd ask how many steps, and then here you do that calculation, this feet per steps calculation, and you get a feet value. Print that out, and then so basically you're putting this at the top, and you're putting this at the top, and you're putting this at the top, and then when it's time to calculate feet, you execute this and print it out. So when it gets time to calculate feet, it executes this, which is this. And then when it comes time to calculate calories, this here, that's the calculations are, it just you put that here, and then you print that out. So you can see this is a little bit more difficult to follow if you look at it and you're wondering what it's doing. So an example, in the example without functions, how many statements are in the main? How many statements are in the main program without functions? Well, 1, 2, 3, 4, 5, 6, 7, 8, 9. That'd be 9. In the example with functions, how many statements are in the main program? Well, it's just 1, 2, 3, 4, 5. It's the main program. It's not the functions. So I think it's 5. I think that's the answer. Yes. Which has fewer total lines of code, including blank lines? The program with or without functions? Well, we can see that the program with functions has more lines. 1, 2, 3, 4. I mean, even if you don't include the blank lines. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Whereas this one is 3, 6, 9. So there's more lines of code, especially when you throw in some blank lines, which you should always do, make it look nicer, make it more readable. So it takes more. Which has fewer? It's the one without the functions. So here's the talk about modular development, and that's what we called it back in the old days when this kind of programming, the structured programming, first came out. Programmers commonly use functions to write programs modularly. Modular development is the process of dividing a program into separate modules that can be developed and tested separately. And this way, if it's a big program, you can have multiple people working on the program, and once the big program is divided up into modules, first it's going to do this, then it's going to do this, then it's going to do this, and you define the interaction between the modules. You don't write the code yet, you just define the modules, and you define the interaction between the modules, and then you can hand out the modules and have different programmers write the code. And as long as they write write their modules according to how they're specified, you know, according to what the parameters are going to be coming in and what's going to be returned or what's going to be output. Once that's defined, then the programmers can go off and do their thing, and then they all come back together in the end, and they take all their modules, put it in the same document, and then you have a main program which calls the modules, and it should work. That's the idea. And so programmer, now when the you know, there's going to be programmers that are writing the modules, but there can also be a programmer still working on the main program, even though the modules are not defined yet. And then so what the main programmer would write where the modules will be, the main programmer writes what are called stubs of the modules. The stubs of the modules are just like you call the module and the module says, okay, I'm here, goodbye. And then the programmer or the programmer can write the stub so it outputs the same value every time, and that way the programmer can test the code, the main module code, without, you know, the functions being defined yet. So of course we know that another reason to do this is to avoid writing redundant code. A function can be defined once and then appear in multiple places in the program. Okay, so we haven't seen this quite yet as an example up above, but we've mentioned it, that the reason one really good reason to write functions is especially if you have code that appears, you know, the same code appears many times in your program. So examples of functions, of such functions, are like the math module has this square root function, and the math function you know, is provided with the math module, but you only have to once that's defined, then you can reuse it many times. The skill of decomposing a program's behavior into a good set of functions is a fundamental part of programming, and it helps characterize a good programmer. Okay, so if you look at that sentence a little bit differently, when you start out, you learn about writing functions. You learn about, you know, oh, I'll take this code and I'll make it a function. There's often lots of different ways that you can, you know, collect up some code and define a function that way, and then use it. And when you're starting out, you might you know, do it a particular way, but you know, it may not be efficient. You might have a little bit of redundant code still in there. You might include some stuff in the function that maybe should not be included in the function. Also, you may you know, collect up some code and you make one function, and really it makes more sense to make two functions out of it that each do only part of the thing of the function, of the part of what your original single function solution had. And so it's just practice, and it's also preference. You know, that it says in here that you shouldn't, somewhere it says you shouldn't have like more than 30 lines of code for a function. Well, you know, it took me a lot of years writing code before I actually got it down to 30. I mean, I would, like, you know, I'd start writing code, and as long as I didn't have anything redundant, my code, my modules would go like 3 or 4 or 5 pages, and it was fine with me, because with a lot of my code that I wrote, it was just me. So and I'm able to follow it. I know how I think, and I'm able to follow it down. But once you start writing code that other people are going to look at, then it's kind of I don't know, impolite, I guess, to write big long chunks of code where you have to remember what happened 2 pages ago to be able to follow, you know, the code all the way through. And so that's when it's good to write functions. But if you have redundant code, for sure you should just, bite the bullet, make a function, and then from then on you can use the function. You may end up modifying the function. You may end up making the function, it starts out being simple, but then you might add some functionality to the function as you go along. You might, you want to do it something a little differently, like converting. You start out by just convert some, Celsius to Fahrenheit, and that's fine, and you go along, and then some other time you have to convert Fahrenheit to Celsius. Well, you could write a separate function. You say two functions, or you could write one function. It's got a parameter. You have a separate parameter where the parameter is the direction, whether you want to go Celsius to Fahrenheit or Fahrenheit to Celsius. You have a parameter, and then it takes in the number, and depending on the parameter, you're going to make one conversion or the other. So that's and then again, that's personal preference. That's you may have a team leader who says they want you to do it this way, and I'd rather not do it that way, but because my team leader wants me to do it that way, and everyone else is going to do it that way, and everybody wants to be able to read everybody else's code, then we do it that guy's preference as opposed to your own. That's just sort of getting along with your team members. But okay, so this the general guideline, especially for beginning programmers, is that a function's definition usually shouldn't have more than 30 lines of code. It's sort of maybe a page of code. We can see it all on one page, although it's not a strict rule. So here we have an example of we're going to compute sizes of pizza. What are we computing? Total area of pizzas, and we're going to do it for two different pizzas. We're going to do it for a pizza that's got a diameter of 12 and a pizza that's got a diameter of 14. But you see the code here. This code is pretty much the same. It's the same as this code, except for the variables are different. So and so I guess we want to do, we have two pizzas and we want to compute the total area. So instead, we take this, well, actually we take all this and we create a function out of it. So we have the pi, which is there. And then instead of having pizza diameter 1 and pizza diameter 2, we have a parameter just called circle diameter, and circle diameter is going to be either pizza diameter 1 or it's going to be pizza diameter 2, depending on which pizza area we want to compute when we call this function. But the operations inside here are the same. This is the same as this, except for this name is different. Anyway, so here we can down in the main program, we can still call it pizza diameter 1 and pizza diameter 2, and then we call this function that we defined. And the first time we want to do it for pizza diameter 1, so that's the argument to the function. And so the first time the function executes, it does it for diameter 1, and the second time it does it for diameter 2. So if the internal statements are revised, all function calls have to be modified too. No, I don't think so. Yeah. The benefit of functions is to increase redundant code. That's silly. It's to decrease redundant code. All right, here's a challenge activity. Let's see. 6.5. All right, so write a function so that the main program below can be replaced by simpler code that calls a function named this. So the original program is miles per hour. So we input a miles per hour, we input a minutes traveled, and then we compute the hours traveled, and we compute the miles traveled. So the okay, and then we print it out. So sample output with inputs. So we input miles per hour, we input minutes traveled, and then we've got a function, and the function is going to be def this. Copy, paste, and we're going to have to have this one come in and this one come in. That's this one and this one. So parameters are going to have to be, okay, so how do we call this? This is the function that we call, that's this. And it takes the miles per hour first, takes this one first, takes this one first, and it takes this one second. So I'm just going to copy this here. Copy. And I'm going to do tab paste. Okay. I'm going to tab that in there. So I got to return something though. I got to return, miles traveled. That's what I want to return. So I want to return miles traveled, it looks like. Miles per hour and minutes to miles. I want to print miles traveled. I am printing miles traveled. So I guess I'll turn this off. Enter, return miles traveled. Okay. Oh, jeez. I turned that sound off. I don't know if you heard that. But, so we read in miles per hour, we read in minutes traveled, and we pass it in miles per hour and pass in minutes traveled, and we return miles. Yeah, okay. We input the miles per hour, we input the minutes traveled, and we return miles traveled. This. Okay, yeah, so this should probably work. I forgot to put the parameters here. Well, you can put the parameters there. You know what to put there. Put this there. All right, so anyway, you can fix that. I don't want to tell you everything. Okay, here I was talking about stubs. So incremental development and function stubs. So programs are typically written using incremental development, meaning a small amount of code is written and tested, then a small amount of more code is written and tested, and so on. An incremental amount of code is added, and then so that way, of course, each time you got something that works, you add a little bit of code. If it doesn't work, then it was just the code that you just added, and not some huge big thing. The last thing you want to do is write a whole big long program. You try to write the whole thing at once without doing incremental development, and then you run it. you execute and it doesn't work. Well, how do you narrow down what doesn't work? You know, so what you probably do is you start commenting out your code because you don't want to delete it, but you just turn them into comments, and then you end up doing an incremental development that way. But to assist in the incremental development process, programmers commonly introduce function stubs, which are function definitions whose statements haven't been written yet. And so the benefit of function stub is that the high level behavior of the program can be captured before diving into the details of each function. So this is called, we used to call this top-down program development. That is opposed to bottom-up. Sometimes you need to have a little bit of bottom-up. So sometimes you have to define, if you're, the idea is you write all the outside code and then you gradually go down and you write the little functions down below. But sometimes you might not even know how the little functions down below, like what they're going to produce. Like if you're writing some functions that interface to some physical device, where you got some signals coming in, and you don't know if it's you're reading in temperature, and you don't know what the range is going to be, and so sometimes you might want to write the little functions first to see what comes out. And then once you really know what's going on, then you can go back to a top-down development like what they are suggesting that we do here. But presumably with these programs that we're writing now, we're going to know how to write the little functions when it comes time to writing them, so we can try to do strictly a top-down approach here. So the benefit of a function stub is the high-level behavior can be debugged. Capturing high-level behavior first may lead to better organized code, reduced program development, and even code with fewer bugs. I like code with no bugs. A programmer writing a function stub should consider whether or not calling the unwritten function is a valid operation. So simply doing nothing and returning nothing may be acceptable in early development, but and if you're going to do that, then you can use this pass keyword. So there's actually some statements in Python that help you with that. Oh, I forgot to add the colon. Okay, sorry. Oh, yes. Somebody very smartly just pointed out that, well, it's not, it's gone now, but anyway, sorry. Yeah, yes, so everybody can see the comment there. That was one of the errors in my code. All right, so in this little example here, we're gonna write a program to compute the calories, the feet and the calories again. And so we have a function that does the feet, and we have that, maybe we have that there, but we haven't written the function that takes steps and converts them into calories yet. So we can just put a pass statement there, and it'll just return. When you're defining a function, you have to have at least one statement in the function. And if you don't know what you're going to do yet, you can just put this pass statement there. And then when it's called, it'll just return. It won't do anything. It'll just call and return, but it won't cause an error. And so here we see that when this thing is executed, when this is called, it's not going to pass back anything. It's going to probably pass the none keyword here, which means it's got no value at all. Got no type, got no value. Another way to do a stub is to actually do a print statement. And so here's another example. You can just print out this "fix me," kind of thing here. Where here's an example. Okay, that's another way. A third way is to, as they say, raise an exception. And we will learn more about raising exceptions later on, but Here you can raise a non-implemented error. And so that's where, for example, if you're debugging, you're well along and you're writing your code, and you may have some functions that you haven't defined yet because they shouldn't be executed yet, like maybe some error checking or something, but you still have the stub there. But if something should happen and that function actually gets called, you want to know about it. In fact, you want to stop the execution, and the error is that the function was called and it shouldn't have been called. So then you can put this, you can raise a non-implemented error exception. It's called an exception, and then it'll just stop. So it'll print out some errors. It'll print out this. And that's kind of like dividing by zero. If your code divides by zero, that causes an exception. It's an invalid operation kind of exception. Incremental development may involve more frequent testing, but ultimately leads to a faster development. Yeah, I think it does. Main advantage of function stubs is that they ultimately lead to faster running programs. Faster running? I don't know what they mean by faster executing or getting faster. I think it's false. Yes, they just help the programmer, correct the high level behavior before getting distracted in the low level details. If you don't use stubs and you're writing some program like this, you start to write the definitions and you get bogged down in the details of the definitions, and you finally get that to run, and you come back then you have to test it somehow, but you finally are convinced that runs, and then you come back out and you got to do the high level stuff again, and it's hard to keep track of that stuff because you're changing context all the time. And so that's why incremental development using stubs can help with that. The pass statement should be used in a function stub when the programmer wants the stub to stop. No, that's stop execution. That would be the raising the exception. So this is false. Yes, raise that when you want to stop. When you want it to halt. Okay, here's another challenge activity. Define stubs for the function. Define stubs for the functions get user num and compute average. Each stub should print fix me with the finish and then the function name, followed by a new line which should return a -1. Each stub should also contain the function's parameters. Okay, so let's say, so when you run this program, so it's going to do 2 calls to a get user num function, and then it's going to do 1 call to a compute average function. And so it should print out this, and then it should print out this, and then print out this, and then it should print this. And so here we have down here, we've got a user num, and then it prints out an average of the 2. And so this is the upper level. This is the higher level, the main program, reading in 2 user numbers, and then we're computing the average using a compute average function. So we want to write stubs. So we have to have a stub def get user num, and it doesn't have to have a parameter, I guess. Make sure to put the colon there, and we can just we want to print out this. This, copy, print that, okay, and return a -1. Okay, and then we've got to do the same thing for this one. So we're going to do copy this. I'm going to go, I thought I shut this off. What's going on? Oh, I shut it. What? Def that colon, and I'm going to print out. All right, it's just going to be the same thing again. I print this. It's funny I don't write out the, oops, print. And return a -1. I wonder why I don't, doesn't it say you should? Each stub must also contain the function's parameters. All right, oh, it's not going to display the function's parameters. Okay. All right, this might work. Yeah, it did work. Okay. All right, what's next? Functions can have branches and loops, of course. They're just programs. And so here's an example of a program that's going to compute the eBay fee. And I guess the eBay fee is, if it's the selling price is, okay, there's going to be a base fee, which is 50 cents. It costs 50 cents, no matter how much you're going to ask for it. And if the amount you're asking is, or seller, I don't know. I've never sold anything on eBay. I bought stuff on eBay. But if the amount is $50 or lower, then there's this 0.13 returns the fees charged by eBay given the selling price of fixed price books, movies, music, and video games. The fee is 50 cents plus 13% if the selling price is below $50, below up to and including $50. If it's greater, if it's between $50 and $1,000, it's only 5%. If it's above $1,000, it's only 2%. So in this function, we define these percentages and we name them appropriately. And then there's this fee. And so, and then in the parameter to this function is the selling price. And so if the selling price is less than 50, it just, okay, they all have the fee. It all starts out with a fee of 50 cents. And then if it's less than $50, you take the selling price and you multiply it by the under $50 percentage, and you add that to the fee. If it's between 50 and 1,000, I see how this works. The first $50 is going to be charged at the $50 fee. And then the remaining up to possibly 1,000 is going to be charged at the at that fee. So if from $0 to $50 is for whatever you're selling, the first $50 is going to be charged 13%, and then from $50 up to $1,000 is going to be charged the 5% fee, and then anything above that is going to be charged an additional 2% fee. So that's why we put the 50 times the 50 and under fee, and then we take the rest of it, which is what the selling price is, minus the $50, because that first $50 is taken care of in this first term. We multiply that by this, and then the same thing for the greater than $50, or greater than $1,000, that is taken care of here. So that's why it looks like that. Okay, this means continue on to the next line. That's all, and then we return the fee value. So for any call to eBay fee, how many assignment statements will execute for anyone? Let's see. 1, 2, 3, 4, and then one of these. So 5. 5. Yes. What does eBay fee return if the argument is 0? So in other words, if it's if you want to get rid of something for free, you're still going to have to pay the fee. So the fee is 50 cents. You're still going to have to pay 50 cents. Show your answer of the form hashtag point hashtag, I don't know, 0.5. Let's see if it accepts this. Yeah, good. What does eBay fee return if the argument is 100? Show your answer in terms of that. Okay, so the first is going to be 30. It's going to be, I'm sorry, 50 cents plus, but it's a hard one. Let me, okay, so we are selling it for $100. If it's $100, it's going to be this one. If it's $100, it's going to be this one. So that is, let's see. It's going to be, we're going to start out with 30 fee. It starts out 50. Why do I say, the reason I say 30 is because I know for PayPal it's 39 cents, so it's instead of 50 cents. So fee starts out equaling 50 cents. And then we're going to add to it this 50 times P50, and P50 is 13 cents. So plus 50 times whatever this is, 13 cents, 0.13 plus this. And so the selling price is $100, right? That's what we're doing. Selling price is $100. It's the selling price. And so the third one is going to be selling price minus 50, which is 50 times that 0.05, 0.5. And so this is going to be, what's 50 times 13? Well, this is going to be 50 cents plus 50 times 13 is something like 65, no, $65.650. Oh, I got a calculator. Oops. So what is 0.13 times 50? $6.50, 6.5. And then 50 times 0.05 is 250, or that's 50. It's 25. Yeah, 25. So that equals 32 bucks. I guess that's 32 bucks. Let's see. 32.0. Boom. The first fee is 50, then the second branch will execute. What was my question? What did I do wrong here? Fee plus 50 times P5 is 50, P50 is 0.13. And then this is selling price is 100, so 100 minus 50 is 50. 50 times, this is 0.05. Well, what's the answer? Okay, so what I do, 50 times 0.05 is 2.5. No? 50 times 50 cents. 50 times 0.5 is on my, I'm not adding right or something? Oh, really? Oh, does anybody see my mistake? This should be 0.05. 0.05. 0.13, 0.05. So this is 0.25. So this is 7 plus 0.7 plus 2.5 is 9.5. 9.5. Yes. So I mistakenly took 50 times 0.5, and it should be 50 times 0.05. 0.05. So anyway, that's that. Let's write a function call using eBay fee to determine the fee for the selling price of this, and storing the result in a variable named myFee. My fee equals eBay fee of 1523. All right. Okay, user-defined functions to make a program easier to understand. Okay, so the problem below uses function getNumbers to read in a number of to read in a bunch of integers, and then there's 3 unfinished functions. And so what this does is you read in 5 integers. It reads in these 5 integers, and then it prints out what the 5 integers are, followed by numbers 0, 1, 2, 3, 4. So you read them, must read them into this array, and then you print out the array. And then what it does is it prints out all the numbers in a line like that, and then it prints out just the odd numbers, and then it prints out just the negative numbers. So we're supposed to finish these. So we're supposed to finish this. So I'm going to open this up, and I'm going to copy this. Size is 5, I see. Copy. And I'm going to paste it here. And I'm going to start just by reading. I'm going to see what happens when I just run this. Okay, let me just run this now. So I'm going to save it. Make sure I save it, and I'm going to run py test.py, and it asks me for 5 integers. 599. Can I do it this way? 99 minus 44, 0, 12. Does that work? Yes. Okay. And all it does is print out this numbers and odd numbers and negative numbers, because first we read in the size is defined up here, and then we read in those 5 numbers, and that's this method right, or this function right here. And basically we declare a how does that? Okay, I'm wondering about the scope. Oh, returns. Okay, so we return the array. Got it. Return the array. And then we return the array, and then we use the array is the it's not called an array, right? It's called a list. Is the argument. So it reads in the argument, it reads in the list, and then it just displays it. It takes those and it loops through them. Okay, so the first one should maybe print all the numbers. So it's got numbers. I can do for num in numbers. I'm going to have a out equals nothing. Out concatenate onto out the num plus a space, and then I can print comma out. Does that work? Let's see if that works. All right, what am I doing wrong? Let's see, this is not. Okay, for n in range of length of numbers. Does this work? I'm trying to code on the fly here. Out equals numbers of n. That work? Does anybody want to tell me what I'm doing wrong? I'm not remembering my syntax here. The syntax of getting my languages mixed up. It should be some fruits. How do you do length of a list is the len function. Am I looking at the right error? Oh, indentation error. What am I? It's because when I copied it over, this is a tab. Should be a tab. Tab, tab, tab. Does this fix it? Yeah, now it works. What were the numbers again? 5. I do like this, right? 99 minus 44, 0, 12. Unsupported operand type for plus. So maybe I should do this, str. Bet you that'll work. Um, 99, 5, 99, 44, 0, 12. Okay, so this did that one right. And almost done here. I got 2 minutes. And I can do same thing. Same as this. Okay. Print out all the odd numbers. Start with out equals nothing. And then for n in range of len of numbers. If numbers n mod, that's a percent, 2 equals 1, then it's odd. Only then do I say out is plus equals string of numbers n plus this. Okay, and I can print out. And then the last one is going to be print negative numbers. So let me just copy this. I'm just going to copy this. Copy, put this here, and I get if numbers is less than 0, then do that. Okay, and I got to make sure my indentations are right. I hope they are. Well, let's see. It'll tell me. Yes. Odd out. Okay, so this indentation is not right. Well, it's not, doesn't like the odd numbers one, okay? So what's that there for? So I'm gonna do this. Dun, 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 dun. Bump, 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 and I'm gonna do tab, 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 tab. Does that fix it? Yes, negative numbers. Select all this, shift tab, shift tab, shift tab, then tab, and then tab, and then tab, tab. And now when I run it, I can enter in 599 minus 44, 0, 12, and it prints out that. Now, what happens if I copy this? What happens if I put this here? and I put this, copy that, and put that here. And I copy this, put it here. See if it works. Anyway, I guess it works. All right, how far did we get? We only got to 6.7, didn't we? Let's see. All right, well, I guess I'm gonna have to speed it up next time. So I will leave it there, and I guess I'll have to speed it up next time. We'll try to get through this, and we'll see you next week. Any questions?
Thank you.
All right, hearing none. This meeting is adjourned. See you Thursday.